Adding AI capabilities to robots starts with adding vision capabilities. So let's add cameras to the Intel Physical AI Studio. Before we start, make sure your cameras are detected and have the most updated drivers. How many cameras do you need? Which types? And where should they be placed? Good questions. Humans rely on two slightly separated eyes to perceive depth in 3D. Similarly, in imitation learning, camera setup plays a critical role and should be chosen carefully. There are many approaches and opinions, but most papers converge on a common baseline. A typical setup includes at least two RGB cameras, an overhead camera, what I call the macro view, positioned above the workspace. This camera provides a global view of the entire scene, helping the model understand the overall context and object locations. And an arm-mounted camera, what I call the micro view, placed on the robot arm, ideally close to the gripper. This camera captures fine details and maintains visibility of the object during manipulation, especially when occlusions block the overhead view. Together, these views complement each other, combining global awareness with precise local perception. So, one camera can work, but two will probably perform better. Adding a third camera can provide additional useful perspectives, though more is not always better. Beyond a certain point, extra cameras tend to offer only marginal improvements while substantially increasing computation cost during training and inference. It ultimately depends on the setup, the complexity of the task, and of course, the cost. You can use 3D cameras like Intel RealSense, which can be very helpful for high-precision tasks or when dealing with complex geometries. But 3D cameras can be noisier, more sensitive to lighting conditions, and more expensive. In many cases, a standard RGB camera is sufficient, and even adding another RGB camera can still be a more cost-effective solution than adding a 3D camera. Configure the new camera. I have two USB cameras connected. Let's take a look at that one. Choose the resolution and the frame rate. Now I can see the camera. I'll call it the gripper camera and add an additional camera. It's a good idea to have at least two cameras capturing very different angles. This is my top camera, and now it's a good time to make sure it captures the full movement of the arm and the lighting conditions are good enough. You can expect any USB camera or a Bustler camera to work. If you have a RealSense camera, make sure the drivers are updated. You can use it here as its USB camera using V4L2 Video for Linux, or you can add this camera from this menu and use the RealSense SDK. And you can also connect an IP camera, just supply the address. Few notes on the camera resolution. The video recorded from the cameras will be used as an input to the model. Higher resolution or frame rate can improve the accuracy, but will also increase the computational cost. For example, moving from VGA resolution 640 by 480 to 720p roughly triples the number of pixels, and in practice, this extra detail is not always necessary and may not be fully utilized by the model. Most imitation learning models operate on relatively low resolution inputs. A common setting is 224 by 224 pixels. And while some models support flexible input sizes, using full HD images is uncommon due to the computational cost. That means that if you record data at a higher resolution than the model expects, the images are typically downscaled before being used for training. We recommend using 640 by 480 at 30 FPS by default if the camera supports it. Now, let's define the full environment. Give it a name, add the follower and the leader, add my 2 cameras, and here is the full environment. 2 robots, 2 cameras, ready to start the dataset recording. The Intel Physical AI Studio. We saw how to set up the environment. Next video, let's see how to record the dataset. See you there.